Hello students, welcome back to my channel. Let us continue learning database concepts. So in the previous session, we have completed learning everything about ER diagram, the different notations, the different way of representing the ER diagram and how they are related to the data stored in a database. In today's session onwards, we will be learning about relational algebra. Now, what is this relational algebra? Algebra, we all are aware, something which we have studied in mathematics, isn't it? Now, similar algebra or computations operations we are going to be learning, which is related to the database, okay, especially the relational database. That is why it is called as relational algebra. So remember, database is nothing but collection of data. When this data is stored in the form of rows and columns, we will call it as a relational database. We have seen chords rules and different types of rules which will define the relational database. Now, a certain set of operations that I'm applying on this relational database is called as relational algebra. So see the definition here. Relational algebra is the formal description of how a relational database operates. So different operations, functionality of a relational database is nothing but relational algebra. An interface to data stored in the database itself. So relational algebra is an interface. Okay, so if there is a user and here if it is my database, how am I going to perform certain operations? So user might wanting the data in a certain way. Okay, he might want only the columns, he might want only the rows, or he might be wanting only certain data. Such type of operations is performed, or such type of a data is retrieved from the database, and who is the interface for that? That is nothing but your relational algebra. And it is the mathematics which underpin SQL operations. Okay, so this is a kind of a mathematics. Relational algebra is kind of a mathematics who underpin the SQL operations. Now SQL operations in detail we are going to be learning when it comes to the next chapter. Okay, we will try and do certain practicals also, but remember this relational algebra is also the fundamental base for that particular SQL operations. Okay, so this is about your relational algebra. So before getting on to learning in depth about the relational algebra, let us see certain terminologies used in relational algebra. First, we are going to be using the term called as relation. Relation is nothing but a set of tuples. Now, what is a tuple? Tuple is nothing but a row. So when I am saying the set of tuples is nothing but, in normal term we will call it as a table. That itself, in a relational algebra term, I'm going to call it as a relation. So if I'm having two tables, then I will call, if this is a student table, then I will call this is a student relation, and if this is an employee table, I'm going to call it as an employee relation. Next, I have a tuple. What is a tuple? A collection of attributes which describe some real world entity. Okay, so tuple is nothing but, you can also call it in other words row. So row is nothing but a collection of columns. These columns are called as attributes. So what does this row represent? For example, in case of a student table, each row represents a particular information of one student, isn't it? So one student, that is why it is nothing but a real world entity. One student is a real world entity. His attributes, what are his attributes? It can be name, register number, class, course, address, all those things becomes an attribute, which is nothing but a column name. So remember, a a row becomes a tuple, columns becomes an attribute, row and column together they form a relation. Okay, so attribute we have seen already. Domain, what is domain? A set of atomic value is a domain. What is the meaning of that? For example, if I say mobile number, what is the domain value for this? Okay, all the possible mobile numbers, 10-digit mobile numbers, it can be starting from 7, it can be starting from 8, it can be starting from 9, etc. All the possible values is called as a domain. For example, suppose a particular organization or particular college is offering only BCA and BBA, then the domain for course becomes BCA and BBA. Okay, so this is a limited domain. So remember, domain is a set of atomic value which is possible for that particular attribute. What is a set? a mathematical definition or a collection of objects which contains no duplicates. So when I say set, it is a collection of objects which do not have any duplicate. So this also I can call it as a set, right? I hope the terminologies which we are going to be using in the coming sessions are clear. With that, let us move on to the operators. Okay. So for operators, especially write, we use following, that is insert, delete and modify. This is the relational algebra operators we use in order to, if I want to especially write. So what does an insert does? It provides a list of attribute values for a new tuple in a relation. So if at all I'm using an insert operation, it is nothing but if I have a relation, I am going to use the insert and I am going to add another tuple. That is nothing but my insert operation. Okay. Delete provides a condition on the attributes of a relation to determine which tuples to remove from a relation. Okay, basically delete, you can understand that it is nothing but I'm going to be removing a particular row based on what? Okay, there may be a situation, for example, a student with register number 103 has left the college. Okay, he has cancelled the admission. So in that case, I will access the database and I will try to find a match where register number is equals to 103. That is, delete a row from this particular database, that is your student relation, whose register number is 103. That is what is the meaning of this statement is. So provides a condition. So what is the condition here? Condition is register number should be 103. If it is matching, then I'm going to delete that particular row. That is your delete operator. Next is modify. Changes the values of one or more attribute in one or more tuples of a relation as identified by a condition. Once again, I want to change certain detail. For example, for this particular student, I want to change his mobile number. Okay, mobile number I want to change from before something was there, now I want to change. So I'm going to use a modify operator. Using that, I'm going to change. So how will I change? There is, when I say it is a college, there is going to be n number of rows, isn't it? So in that case, I will once again find the register number. So now remember, in both the examples, I'm going on to talking about register number in order to identify an row. Why is that? That is because we have spoken this because before, primary key. Here comes the concept of primary key. Only register number is the attribute which can uniquely identify. Even if there are thousands of students, all 1,000 students will have 1,000 register numbers. So it is going to be unique. So that is the reason when I'm putting a condition, I'm putting it on a primary key. So it will uniquely identify each row. Similarly, if I want to modify a particular student's mobile number, then I will make sure that register number is, for example, 105 is the student whose mobile number I want to change. Then I will use a modify operation. Condition should be the register number should be 105, and then I will say modify the mobile number to the recent one, whatever it is. Okay, so this will make the modification in the required field of that particular database. So this is your operators for write, that is insert, delete and modify. I hope this is clear. Next, let us move on to the operators retrieval. Okay, so retrieval, when I say if I want to retrieve a certain kind of a data from the database, there are two groups of operations which we can perform when on the database. First one is your mathematical set theory based relations. Okay. Second one is special database operations. So now what is this mathematical set theory based operations? They are union, intersection, difference, Cartesian product. Okay. So union, intersection and difference you would have studied in your discrete mathematics already. We are also going to see in brief. Cartesian product is something new for us. So we will see in detail what is the meaning of that. Next, special database operation itself, we have something called as select, project and join. Okay. So in today's session, we will be exclusively focusing only on the mathematical set theory based relationship. Now let us see them one by one. So set theory, before we apply it on our database, there are certain conditions which need to be matched. Okay. So there are certain requirements on which, based on which we will be applying these operations on a database. So for set operations to function correctly, the relations R and S, remember all these set operation, retrieval operation, we will be performing on two relations. In other words, we are applying this on two tables. So every time I talk about relation, remember I'm talking about tables. So that is why we discussed the notation in the beginning. So set of operations to perform function correctly, the relation R and S. So we are taking two examples, R and S must be union compatible. Okay, it should be compatible to union. So what is that? The two relations are union compatible if they have same number of attributes. Okay, which means if I'm having two columns here, it cannot have three columns over here. That is not allowed. Same number of attributes. So attribute is nothing but the columns. So same number of attributes they should have. This is not allowed. But if I have another table, if this is R, this is S, this is not allowed. If I have another table Q, then this is allowed. Okay. The domain of each attribute in column order is the same in both an R and S. Okay, domain we have already seen. Domain is nothing but the set of possible value, atomic values. Okay, so here if I have a mobile number, okay, and if I'm allowing 10 digits here, and here in Q I'm saying that here 5 digits are allowed, then this is not compatible. Okay, the domain should be same for both of them. For name, if I'm allowing special characters here, and if I'm not allowing special characters, once again the domain is not same. They should be of the same data type, right? So those are the two conditions for us to find out whether two relations are compatible or not. That is, number of attributes should be same plus the data type, or the domain values should be same in both the relations. Okay, with that requirement, let us go to the first operation, that is your union, right? So consider two relations R and S. Union of R and S, the union of two relations is a relation that includes all the tuples that are either in R or in S or in both R and S. Duplicate tuples are automatically eliminated. Okay, so union we have already studied. Even when it comes to Boolean algebra, or when it comes to mathematics, we have studied already. So if this is a two sets, it contains all the tuples. So in our case, if I have a table R, okay, so I'm having remember, see here I have two attributes here. In S also I'm having two attributes, same set of values are there, so they both are compatible. So when I say union, the union R union S, or it can also be represented as this, R union S is nothing but combination of both the tables. So I have A here, but I also have A here, but since it is duplicate, I am not going to write it. Okay, duplicates are eliminated automatically. Similarly, B here, but B is not there here, but then in the resultant it is going to be there. I have D here, I have D here, C, C. The D again, once again it is duplicate, so D is duplicate and A is duplicate, so we are going to eliminate, we are going to write it only once. Once again, E is also duplicate. Okay, in this case, remember, sorry, this is E is not duplicate. Now what is happening here for E is, when it comes to E, the column value E and 5 we have, okay, so which is already written over here. But when it comes to S, that is your S relation, E, the first column value is E, but the second column value is 4. Hence, it is not a repetition, we are going to take it as a new value. Remember, each row represents a particular real world entity. So it can be possible that there is a person named Priya and her address is, for example, Bombay, and there may be another Priya whose address is Chennai. So we cannot say that these are duplicate. Okay, these we will consider it as an individual. So that is what is happening here. Since the values are differing, what we are going to do is we are going to keep both of them. This is our union operation. I hope this is clear. Let us move on to the next operation, that is your intersection. Intersection of R and S. So intersection of R and S is a relation that includes all the tuples that are both in R and S. Remember this. The resultant table will have a tuples which should be present in both R and S. So I have A here, hence it is there in the result. B I have here, no, there is no B here. C I have, which is not there here. D, yes, I have D3, hence it is there in the resultant. I have F4, yes, it is not there here. I have E5, but I don't have E5 here. Instead, I have E4. Same example you can consider. Priya Bombay, Priya Chennai. They are two individuals, so it is not repeating. Hence, I'm not going to write the name of that particular row or keep that particular tuple in my resultant. Okay, so that is why I'm going to keep only these two tuples in the resultant. So this is your R intersection S. As you can see in the diagram, when two tables are joining, whichever is the common is only going to be in the resultant table. That is your intersection of two relations. Next we have difference. Okay, so what is this difference? Difference is just like our subtraction, how we use. The difference of R and S is the relation that contains all the tuples that are in R but are not in S. Okay, so here you should be careful that whether you are writing R minus S or you are writing S minus R. Okay, so why? Because when I say R minus S, I'm going to take away all the tuples which are there common in S and R, and I'm going to retain only the one which is there in R. Similarly, when I say S minus R, I'm going to take away all the common tuples which are there in R, and I'm going to retain which is there in S. Okay, so if you're not understanding, let us see this diagram. So here A difference B, when I'm subtracting A minus B, so I'm going to have all the values which are there in E. Whichever is common in A and B is also going to be removed, plus the B values are going to be removed. When I say B minus A, which is means that I'm going to keep the values of B, whichever is common, I'm not going to keep it, as well as I'm not going to keep the value of A, right? So this is the Venn diagram. Now see this example here, table. I have R table, I have S table. So if I say R minus S, once again, which what I said, I told you that I'm going to keep all the values of R. Whichever is common, also I'm going to subtract, and whichever is there in S also I'm not going to keep. Okay, let us see which is common. A minus 1 is common, so I'm not going to keep it. B2 is here, B2 is not here. So this is eligible to be there in my resultant table or relation. D3 is common, so D3 I'm going to remove. F4 is not there in S. Okay, so F4 will qualify to be there in the resultant relation. E5 is not there here, so E5 also is eligible to be there in the resultant relation. Again, leftover whichever is there in S also we are going to neglect it. This is your R minus S. Similarly, let us see now S minus R. Okay, what happens in S minus R? So I'm going to keep all the tuples which are there in S, and the common one with the R I'm going to remove. Okay, so A1, it is common, I'm going to remove. C2, okay, this is not there, so this is eligible. D3, yes, it is common, so I'm going to remove it. E4, no, it is not common, so I'm going to keep it. Where in which E5, F4 and B2 I'm going to remove because I don't need R, because it is S minus R. Okay, so this is your difference of two relationship. And the last operation of the today is Cartesian product. Now this is a very important operation, students, as because in the coming sessions, especially when SQL and all those things, when we are learning, and we are going to be learning the different select, join, intersect, all those operations, Cartesian product comes handy. Okay, so initially we will be learning them in detail. Later on you need not do it so in detail, because you will understand how it's going to work. Okay, so the Cartesian product is also an operator which works on two sets. It is sometimes called as cross product or cross join. So remember this, the difference name for Cartesian product is cross product or cross join. What it does, it combines the tuples of one relation with all the tuples of the other relation. So because we are calling it as a product, remember we are going to multiply, kind of a multiplication. Okay, so there is nothing to get confused. So remember, I will take R and I will take S. So Cartesian product is represented with X, okay, or multiplication symbol. So when I say R cross S, or sometimes it is written also as R cross S, it is nothing but I will take the first tuple of R and multiply with all the tuples of S. Okay, multiply or join. Similarly, I will take the next tuple and I will multiply with all. Okay, so let us see one example. So I have R and S here. First, I will take the tuple A1 of R and I'm going to multiply with all the tuples. Okay, so it is going to be A1 as you can see here. Then it is going to be A1 C2. Okay, then it's going to be A1 D3 over here. Then it is going to be A1 E4. This is the fourth. This is the resultant. Remember, this is actually continued this way. Since there is no space, it is written over here. So this is actually the continuation. Next, after once I completed with the first row or the tuple, I will start with the second tuple. So B2, I will multiply with A1, which is this one, B2 C2, B2 D3, B2 E4. Okay, I hope you're understanding this. You can write it down simultaneously when I'm explaining. Next, I'll go to the third one, D3A1, D3C2, D3 D4, D3 E4. Okay, so D3 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 E4. And the last one, not the last one, the second last one, F4A1, F4C2, F4D3, F4E4. Okay, so F4A1, F4C2, F4D3, F4E4. Now the last one, I have E5 A1, E5 C2, E5 D3, E5 E4. So all the E5 multiplied to the other one. So this is going to be my resultant. So how many rows are there? So we have here totally 5 tuples in R into we have 4. So 5 fours are we have 20. So you can count here. The resultant Cartesian product will have 20 rows. That is nothing but multiply. This is your Cartesian product. What is the purpose of this? What is the use of this? All this we will be learning in the coming sessions, but you should know how to do a Cartesian product. Okay, students. So in today's session, we have learned all the mathematical operators which we are going to be applying on the relational database. So this is the relational algebra operation mathematics. Okay, thank you for watching, students. Hope these sessions are helping you all in your studies. Do let me know if there is any other subject you want me to take up next, and do subscribe and like the channel, and please share it with your friends. Thank you for watching. Keep learning.